When we're comparing fractions, there are two things we need to remember. One is that the numerator on top is telling us how many pieces we have, and the denominator on the bottom is telling us how big those pieces are. So, how many? And the denominator, how many times it was cut. Remember, like 1/2 means I had a hole and it got cut into 2 pieces. I'm taking one of those. 1/10, I have a hole, it got cut 10 times. Oh boy, this is not going to be a very good drawing. And I'm taking one of those pieces. And, 2/3, I had my hole, it got cut into 3 pieces. I'm taking 2 of those. All right, so when we're comparing fractions, in these, my numerator is the same. So these are both only one piece. And now we're saying, well, how big are these pieces? This one got cut into fifths. So it got cut into smaller pieces. This one got cut into 2 pieces. So these are going to be bigger pieces than fifths. These are going to be smaller pieces. So if we're wondering which one is bigger, if they're both 1 in the numerator, the one that has a smaller denominator has bigger pieces because it was cut fewer times. If we have the same denominator, my pieces are the same size. So I'm just wondering then, which one is more? And in here, 3/5 is more because I have more pieces. They're all the same size though, because they have the same denominator. If your denominators are not the same, it's helpful sometimes to convert them to common denominators first, and that'll help you see which fraction is bigger. So on this one, I can semi-easily convert this into tenths. And now my pieces are the same size. So now I can compare which is bigger, 3/10 or 4/10. 4/10 is bigger because it's more of those pieces. If your denominators are nothing alike, then you're going to want to use your lowest common multiple of your denominators to convert these into common denominators. So I know my lowest common multiple of 7 and 3 is 21. So I'm going to multiply by 3 on the bottom and 3 on the top to make these into 21 on the bottom. And by 7 here and 7 on the top to make these into 21sts. So now I have 15 21sts versus 2 times 7, 14 21sts. 5/7 is bigger. The other way you can do this, though, is with the decimal expansion. So in your calculator, you can look these up and see what your decimal versions are. This one is 0.666. This one's 0.714. Both of these repeat and continue on, but these are rounded versions of them. So 0.714 is bigger than 0.666. When you're trying to put numbers on the number line, the first and most important thing is to consider, your negatives and your positives, and then what are the whole numbers that it's in between. So -2 and 1/2, we're going to go to -2, and then we have an additional half, still bringing us farther from 0. So -2 and 1/2 is going to land here. 4/3 is going to be out at 4, and then I have an additional 1/3 taking me away from 0. There's my 4 1/3. And then 3/4 does not have a whole component, so in between 0 and 1, it's going to be more than half. It's going to be about right here. These are not perfect placements. If you are asked to draw these, one thing you can do is start between 0 and 1, if it's a proper fraction. Use your denominator to cut into how many pieces. 1/5, 2/5, 3/5, 4/5, 5/5. And then I'm going to go out 2 because I have 2 of them. 1, 2. Here is 2/5. Double checking. 1, 2, 3, 4, 5 pieces, 2 of them. Very similar with 3/4. Between 0 and 1, we need to cut it into 4 equal pieces. And then we want 3 of them. 1, 2, 3.